Okay, so in the first video I did the edge parities and the face, and so now it looks just like a 3x3 because the edge pieces, once you've completed them, they equal two edge pieces are equal to 1 on a 3x3. So you treat them as if you're dealing with the middle slice. So just as we do with solving the 3x3, we start by, we automatically start by making our cross or plus or whatever you call it. Like that. Okay, so I do the same with this, and with someone in mind, inside sort of thing, I'm going to start with the yellow. I'm going to solve it with the yellow side. So here I've got my yellow paired with my orange, or joined up with my red. Sorry, not orange. What am I saying? But yeah, and my green and yellow. Blue and yellow is already there, so I just need to, and then I need to bring that back. So as you see now, I've got my yellow plus. Now at this point, now I have to just put my edge pieces in, or my corner pieces in place for the top. So I'm just going to go ahead and do that without further explaining it. Just simply, okay. This is all, at this stage, it's just like solving a 3x3, and all you need to do is just move them. Always move, just move your edge slices. There's no need to move the middle ones. Okay, at this point. Right, so now we've got our yellow side completely finished. Now, like the 3x3, we just have to get our and just leaving the last side edge piece just to refresh as to how it's done. So there I have, okay, my red and my green. And the green is there, so I have to put it under, so the orange is under the blue. Okay, and I bring down, back, up. Okay, so then that. Right. So now, just like with the 3x3, I've got my first two slices, or in this case 3. These are now being treated as 1 once you've got them together. Now, all that's left to do is the bottom slice. Now, there are a couple of deviations that you may run into when you're solving the bottom slice of a 4x4 that you will not find on a 3x3. But before I do that, I just simply want to finish the side. So, okay. Right, just put all of them in place. 1, 2, 2. Obviously, I'm not a speed cuber. This is not the cube to do it with, as I haven't really lubed it the way it should. Already had a few pieces pop out on me a couple of times. I've had to put it all together. So alright, so we just have to bear with me here. Now at this point I'm trying to avoid what I had before, and that was cubed pieces popping out on me. So just trying not to let that happen. Right. So bear with me here. Okay, so now these, all I have to do is simply put. Now this is what I told you about, where you've got two pieces, two mismatched pieces, and two properly, well, not properly aligned, but they're in the right place. They just need to be flipped. But when we get to this part now, assuming we have to do an algorithm specific to the 4x4, you're not going to find this on a 3x3, or you're not going to have this dilemma. So what we do for the algorithm for this one is simply we go 1, 2. Okay, 1, 2, 1, 2, 1, 2, 3, 4, 1, 2, 1, 2, 1, 2. Okay. Now we've got them properly figured. Since we've got the blue on the top, or behind us in its proper place, but the others need to be moved clockwise. So we do the same algorithm as we do on a 3x3. 1, 2, down. Okay. All right. So we need to 1, 2, 2, 2, 1, 1. Okay. Now this is another scenario you will not find on a 3x3. By the time you get to this point on a 3x3, usually it's either these two or these two. These two are in their proper place. Like you see this. You'll have two opposite, or you'll have 180 degrees or 90 degree, but you never have three flipped up on a 3x3. So this is where I'm going to do the normal algorithm as if this was in place and just these two, which is simply 1 and count to 4. Okay, so now you've got the H in front of you. So 1, 2, 3, 4. Now at this point, this is where you would have completed the 3x3. But on a 4x4, like I said, this is the deviation, and you need to learn the algorithm for it. This is the deviation I was telling you about. One piece, or one edge pair, not properly, that needs to be fixed. So you need to learn this algorithm. It's quite long, but you place this like this is in front of you. This is how it will look in front of you. So I'm going to flip it to my side. So I need to flip these, you know, I need to flip this side. Okay, so I'm gonna, like that, flip it 90 degrees, 180 degrees, another 90 degrees. Okay, then I'm going to go flip it over 90 degrees, one clockwise, one, and then move one over. Okay, 1, 2. I'm going to flip it back, move the other one up, 1, 2, then back down again, 1, 2, down, 1, 2, up, 1, 2, down, 1, 2, et nous sommes finis. So that is how we solve the, this is how we solve the 4x4. Now I will put the notations down later on when I do a little more editing on the video. I'll mark the I'll mark the algorithms as so that they're easier to follow. So this is how we've solved this. So without further ado, I think I'll, I hate leaving tasks unfinished, so might as well quickly just put this one back together too. So 1, 2. Hope it's been easy enough to follow. I did it, I just whipped through it quickly enough, as if, knowing that you knew how to solve the 3x3, or that whoever's watching would know how to solve the 3x3. It's not that hard to learn once you've done it a couple of times. The algorithms take a fair bit of memory work, but once you've got it, you never forget it. So thanks for watching, and talk to you again.